today's chemistry tutorials. I am Benjamin. In this video, we will be learning how to calculate empirical formula of a compound. That is, calculation of empirical formula. Let us look at the meaning of empirical formula. Empirical formula, EMF, of a compound or substance is the simplest formula of that compound. That is to say, it indicates the relative numbers of each kind of atoms in a molecule of a substance. That means the simplest formula you can ever think of is the empirical formula of that compound. For example, writing the formula of water as H2O. That is the empirical formula, which is the simplest formula of water. The actual molecular formula of water is supposed to be 2H2O. So the simplest formula of any compound for easy understanding of such compound is its empirical formula. It actually exposed or indicates the kinds or the kind of atoms present in the molecule of such substance. It is found by determining the percentage composition of a substance by quantitative analysis. Well, let us consider the following examples for easy understanding. An organic compound contains 54.55% carbon, 9.02% hydrogen, and possibly oxygen. What is the empirical formula of the compound? Please, I want to beg your pardon. Never confuse yourself with electromotive force in physics and empirical formula. Don't confuse yourself about it. Empirical formula is written as a capital big letter small m and f, like that. All right, let's see how we can do this. We can actually solve this problem by considering the relative atomic masses of each element present in the compound that is given. If you had not watched our video on calculation of percentage by mass of element and relative atomic mass, do so. It will help your understanding of what we have to do now. Let's go to the board and see how we can go on to calculating the empirical formula. Now, you can see that in the question that is given to us, there are three elements, and each of them have a percentage composition in the compound. Let us start with carbon. The percentage of carbon is 54.55%, and that of hydrogen is 9.02%. That of oxygen was not given, but remember that we are talking about percentage by mass, which means every percentage by mass is equal to 100%. So let us see how we can get that of oxygen, which was not given. Now, let's say that the percentage by mass of carbon plus percentage by mass of hydrogen plus percentage by mass of oxygen is equals to 100. Now, in this case, the percentage by mass of carbon is 54.55. Then the percentage by mass of hydrogen here is 9. This is 9.02. And that of oxygen is not given. That of oxygen is not given, and so we still equate it to 100. Now the total of the percentage by mass of carbon and that of hydrogen is the percentage by mass of carbon and that of hydrogen is equals to 63.57. And then let's say let us call the percentage of oxygen to be x. Let it be x. So we say plus x, which is the percentage by mass of oxygen. And this is equals to 100. It's very simple. Now, at this point now, we have two like terms and one unlike term. So what we do, we collect like terms. So that will give us X, which is a percentage by mass of oxygen, is equals to 100 minus 63.57. It's equals to 36.43. Therefore, the percentage composition of oxygen, percentage by mass of oxygen, is equals to 36.43. All right, you are already there. All right, let's bring all of them together. We start now with carbon. The percentage composition by mass is 54.55. Now divide this percentage by the relative atomic mass of carbon, which is already given in this bracket. It's already given in this bracket down the question. You know, I told you in the previous videos that these relative atomic masses will always be given to you in brackets, so you don't need to worry yourself about it. All right, let's go back to the board. So carbon here is 12, so we bring it down here to be 12. When you divide this, you have 4.545. 4.545. Now we go to hydrogen. Hydrogen here is 9.02% divided by 1 in the bracket. That 1 gives us 9.02. Now we go to oxygen, which we have calculated for. We had 36.43 divided by 16, which is the relative atomic mass. So we're going to have that to be 2.276. 2.276. Now look at these ratios, the ratio 1, ratio 2, and ratio 3. Now consider which of these ratios is the smallest. 4.545, 9.02, and 2.276. Which is the smallest? Now you can testify that it's very simple. 2.276 is the smallest ratio among the three. So what you're going to do now is to divide the other ratios, including itself, with the smallest. All right, let's go to the other side. Now the next statement is divide through by the smallest ratio, which is 2.276. Therefore, for carbon, it's going to be 4.545 divided by 2.276. That will give us 2.01. 2.01, which is approximately 2. And we go to hydrogen, which was 9.02 divided by the smallest ratio, which is 2.276, and that will give us that 9.02 divided by 2. To give us 3.96, which is approximately 4. Now we go to oxygen, which we have calculated, and we see which is also the owner of the smallest ratio. 2.76 divided by 2.276, that gives us 1. This is, therefore, the empirical formula is equals to carbon, the N, the final answer is 2, so C2, and hydrogen, the final answer is 4, and oxygen, the final answer is 1. That is the answer. I hope that was very simple. I hope you got it very right. If you had not gotten it, you go back and repeat as much as you will understand. All right. Let us still take example number 2. An organic compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. This is very simple. What is its empirical formula? And then the relative atomic masses are given in the bracket below. Let's go to the board and you have it. So we have carbon is equals to 40%, and hydrogen is equal to 6.7%, and then oxygen is equal to 53.3%. For this will give us 40 over 12. Where did I get the 12 from? The relative atomic mass of carbon. This will give us 3.33, and we go to hydrogen, it equals to 6.7 over 1. Where did I get the 1 from? Relative atomic mass. This was 6.7, and we go to oxygen, which is equals to 53.3 over 12. Sorry, over 16. This will give us 3.33. Now we have we have the smallest, divide through by the smallest ratio. Now the smallest ratio is which is equals to 3.33, and we have 2 of them here. There's no problem about that. So carbon will be equals to 3.33 divided by 3.33. That will give us 1. Then hydrogen will be equals to 6.7 over 3.33. This will give us 2.01, approximately 2. Then we have oxygen will be equals to 3.33 over 3.33 equals to 1. So we have your empirical formula to be, will be equals to C1, H2, and O1. That was very simple, isn't it? It's very, very simple. You can review as much as you can for your understanding. Now for your assignment. This is your assignment. Find the empirical formula of the following compounds from their percentage composition by mass. A, N is equal to 35%, H 5%, and 60% here. K is 55%, 55.2%, P is 14.6%, and O is 30.2%. Sodium is 83.3%, nitrogen 20.3%, and oxygen is 46.4%. Iron is 44.1%, chlorine 55.9%, and the relative atomic masses of the various elements composing the compounds are all given to you in this bracket. Do it and submit in our comment box. If you have not yet subscribed, please click on the subscription button for more videos.